We're going to move on to Chapter 9 for the remainder of the school year because Chapter 8 is actually where eventually when you take Algebra 2, you'll get into that a lot. I just wanted to introduce it so you had some idea of it moving forward. This 9.1 section that we're going to spend this week and next week working on are all of your different radical expression rules. And so those will come up in geometry, actually this 9.1 stuff. So we're going to make sure we know what we're doing with a lot of different types of radical expressions. Adding, subtracting, multiplying, all that stuff. And what it comes down to is being able to simplify radical expressions, and that is going to use our knowledge of the perfect squares. So if you don't know these, then I would take a minute and write them down next to you. And you should be able to go a little bit higher. You might need to know what 14 squared is along the way. Just make sure you can find it. So what we're going to start with is simplifying radical expressions. Now, when you look at the square root of 36, it means what number times itself equals 36. And the answer to that is 6. So that number squared gives me 36. The square root of 36 is 6. The square root of 50. Now, what I can do, I'm just going to use my calculator real fast and get that the square root is 7.07, etc. That's not the answer that they want when it comes to simplifying. So I'm not putting 7.0710, etc., etc. What I am going to do is simplify the square root of 50 into as simplified as it can be while still being exact without having to round. And so what I'm going to do is factor 50 and look for any perfect square factors that 50 has. So do any of these red numbers, do any of these perfect squares multiply by something else to equal 50? And the answer is yes. 25 times 2 is 50. So what that means is that the square root of 50 is the same thing as the square root of 25 times 2. 50 is 25 times 2, so I'm just rewriting it. By the rules of the radicals, I can split this up into the square root of 25 times the square root of 2. Along the way, like getting into next week, addition, subtraction, multiplication, division, they all have different rules. Multiplication with radicals, you are allowed to break apart like that. So we know the square root of 25 is 5, and we know that the square root of 2 cannot be simplified, so I'm just going to leave it the square root of 2. And if I were to type onto my calculator, I know you can't see it, but 5 times 2 is still that 7.07, or 5 times the square root of 2 is 7.07, etc., etc. But the simplified answer that they're looking for is 5 root 2, not 7.07, etc. So simplifying the square root is breaking it down like that. So let's try another practice problem. Number 2 says the square root of 12. So I want to not just factor 12, but factor it so that I've got one of the numbers is a perfect square, because then I can simplify the square root. So along your list of perfect squares, the only number that is a factor of 12, besides 1, because 1's a factor of everything, is 4. So I'm going to break down 12 as being 4 times 3. And the square root of 12 is the same thing as the square root of 4 times 3, which is the same thing as the square root of 4 times the square root of 3, which is 2 root 3. And if I were to type in my calculator the square root of 12, I'd get 3.46. And if I typed 2 square root 3, I get 3, the exact same thing. But this is the answer that they're looking for, this simplified radical. And if I were doing this problem on my own, I would go from here to here. I show those middle steps so you know mathematically what's going on, but I know that I'm taking the square root of this, so the square root of 4 is 2, and the square root of 3 does not simplify. So I can simplify any square root that I want by trying to find perfect squares. So number 3 is going to say 4 root 45. And that number out front just means multiplication. This is technically 2 times root 3. This is 4 times root 45. So I'm just going to focus on simplifying the square root of 45, and then I'm going to make sure to multiply my answer by 4. So let's start by finding the perfect square that factors into 45, or that multiplies by something else to equal 45. So I'm going to use 9. So 45 is 9 times 5. And the square root of 9, so I'm still taking the square root of that. The square root of 9 is 3, and the square root of 5 is not a whole number, so it's not simplifiable. But I don't want to lose the fact that there was originally a 4 out front. So 4 times 3 is 12 root 5. All right, the last one of these types that we're going to do, number 4 here, I'm going to do the square root of 48. Because I want to show you 2 different ways to approach this problem. If you're looking for numbers that multiply, that are factors of 48, based on your perfect squares, 4 is definitely a number that is a factor of 48, but it's not the biggest number. You can still use it, you're just going to have extra steps at the end. So if it's worth your time, 48 divided by 9 is not a whole number, but 48 divided by 16 is. So I could factor it into, it looks like 16 and 3. Or 48 divided by 4, I could factor it into 4 and 12. And I'll show you that you're going to get the same answer either way. So definitely only feel the need to do this once, but just for the sake of this one problem, I'm going to show you both. So I can either split it up, I'll stick with my color scheme here, to be 16 and 3, or I can split it up to be 4 and 12. Both multiplied equal 48. So the square root of 16 is 4, and the square root of 3 is just the square root of 3, so 4 root 3 is my answer. Over here, when I take the square root of 4 and get 2, the square root of 12 is not a whole number. Now, if you were to type all of this into your calculator, the square root of 48, or 4 root 3, or 2 root 12, you're going to get the same answer, 6.928, etc. But this 4 root 3 is the only correct, completely simplified answer, because look at 12. 12 is not as simplified as possible. The square root of 12 can continue to be simplified because we just did it. The square root of 12 does not just stay the square root of 12. It can be broken down even further. So I'm not necessarily going to show every single step again because really it's just simplifying here. But 12 is 4 and 3. And since there's still another perfect square in there, the square root of 4 is 2. The square root of 3 does not simplify. You don't lose the fact that there was a 2 out front, so you get 2 times 2 is 4 root 3. So the only right answer that IXL would accept is 4 root 3. So make sure that what's underneath the square root is as simplified as possible, no matter what. The 2, the 3, 5, 3 again. And then if you had something like the square root of 35, 35 is 5 and 7, but there are no perfect squares that multiply into 35. So the square root of 35 is also as simplified as possible. So whatever's underneath the square root cannot have any more perfect square factors.